Very good evening. Today we are going to discuss about serial communication in 8051. Today our task is we have to write an ALP program to transfer the serial communication with help of what ECE-D. Assume our crystal frequency was 11.0592 MHz and then our baud rate is 9600. So the first step, whatever the crystal frequency, we have to convert as a machine cycle frequency. So for to convert the machine cycle frequency, we have to divide by 12. And the next step, you have to convert as an UR time interval. So far we have to divide with 32. That is given to timer 1 and then mode 2. Actually, usually in the serial communication, we will use the timer 1. It's dedicatedly used for timer 1 is serial communication purpose. In timer 0, we can use for timing purpose and then counting purpose and then square wave generation. The timer 1 also we have to perform these operations. The timing, counting and then square wave generation. Additionally, we can use serial communication is only able to do in the timer 1, and then always for serial communication we have to use the auto reload mode, that means in mode 2. While we are performing serial communication, serial communication in 8051, we need to know the two register. One is the timer mode register, another one is the serial communication register. There are two registers is used, T mode and then SCON register. The first of all, T mode register, already I told with you, for serial communication purpose we have to use only timer 1. So for you have to make it is timer 1 with mode 2. Mode 2 means 00 means mode 0, 01 means mode 1, 10 means it's in mode 2, 10 it's in mode 2. Then timer 0 you have to disable it, so you can make it as an all or 0. So for its corresponding hex values, so this was this is equivalent to 2 and then this value is equivalent to 0. So we have to configure T mode value as 20. Why? Because means we are going to use timer 1 and then mode 2. So timer 1, so timer 0 we are disabling, so we are making it as an all or 0. And then timer so due to timer 1 mode 2 in we are making it's an 10. We are making it an 10. So the next one is the serial communication. In this serial communication, the mainly the TI-RI interrupts plays the major role. Whenever all the 8 bits are transmitted, TI will be makes as 1. That means timer interrupt flag. Whenever all the 8 bits are received, that RI will be set as 1, and then TB8 and then it's maybe a TB0 and then RB0. It's not a TB8 or RB8. TB0 and then RB0. This is used to add during the transmission. We will add that parity bit with the help of the TB0 and then RB0. Where if you are adding the during the transmission, if you are adding the parity bit means TB0 will be set as 1. During the receiving bit, if you are receiving the data along with the parity bit means RB will be set as 1. So if you are transmitting means receiver should be, if you are transmitting means receiver you can make it 0. In case if you are receiving the data in serial communication, you can make it as an 1. So it's either maybe a 0 or 1 depending upon 0 or 1 depending upon it's a receiver or transmission purpose. So in our case we are going to use serial communication mode 1. So far we are going to make it 0 1. There are 4 modes it's available. 0 0 it's in general, it will be like a shift register. 0 1 it's like a UART mode. So for UART mode we will be make it's a 0. So we will set as a 0 1. It's a mode 1. And then SM2 we will be make as 0. Why? Because it's in whenever if we are using multiprocessor mode, we will make it as 1. Otherwise it will be make it as 0. And then the remaining flags, these are all flags, so you can make it as 0. Whenever all the 8 bits are transmitted, the TI will be set as 1. Whenever all the 8 bits are received, TRI will be set as 1. So you can make it as 0 initially during the configuration. So serial communication we are going to use mode 2, so its corresponding value was 4, then its corresponding value was 0. Okay, corresponding values are 0. So SCON is always, it's maybe a 40 or 50. In case if you want to only transmit, you can make as 40. Otherwise, if you are receiving some data, means you can make, receiver should be enabled. So it's you have to make REN as 1. So it will becomes, instead of 4 we will change as 5. It's maybe a 40 or 50. Okay, fine. The first step what we have to do means we have to convert the machine cycle frequency. So what we do, we have to divide by 12. So 11.0592 megahertz divided by 12. So we will get as 0.9216 megahertz. The next you want interval division. So for your interval division, you have to divide by 32. So while we are divide by 32, what will be happens? It will becomes 28, 800. It will becomes for 9600 baud rate, we have to divide the 28800 with 9600. So in our given question it's 9600. In case in your question it becomes 4800, you have to divide with 4800. So you will get the value was 28800 divided by 9600. So we'll get the value was 3. So load count, the load count means whatever we are going to load the value in the timer 1, that is a load count. So the maximum count minus desired count plus 1. The maximum count was the FF. Why? Because it's an FF, it's in mode 2. Mode 2, it's an 8-bit mode. 8-bit mode, so the maximum value was 256. So the corresponding value is FF. So FF minus desired count was 3. So it's a desired count. Okay, this was desired count. So FF minus 3 plus 1. So we will get as value as FD. So the FD we have to load in the TL1 and then TH1. So both we have to load with FD only. Why? Because in this mode 2, it's an auto reload mode. Whatever we are loading in the timer higher byte, the same thing we will be loading in the timer lower byte. Whenever the timer higher byte will be overflows, it enables the buffer. So whatever it's available in the TL, it will be automatically reloaded in the timer higher byte. Okay, let me discuss about how the program will be runs. Okay, so origin will be starts with 0 0. I told with you timer mode should be a 2 0. We are discussing about that timer mode is an 2 0. Timer mode value was 2 0. So it's an 2 0. We have loaded it in the timer 0. And the next step, TH1 TL1 value. TH1 TL1 value is, so TH1 TL1, the both values are same. So that's an FD. So we are loaded with FDH. FDH we are loaded in the TH1 and then TL1, and then SCON register value, it will becomes SF40. Only we are transmitting, so it's an 40. In case if you are receiving means so REN we have to make as an 1, so 50 will becomes SCON. There is two possibilities, it's maybe a 40 or else 50. So we are making SCON value was 40, and then next step was set bit timer run bit. That means we will start the timer run timer 1 by using that set bit timer run command, and the next move A comma has E. So the E character will be transmitted to the E character will be gets in the accumulator, and then a call trans. It's an trans is a subroutine program. We will call the subroutine program. So whatever the content is available in the A register, that means accumulator. What is available? The E was loaded in the accumulator. That will be moved to SBUF register. Once the data was transmitted to TX pin means TA will be set as 1. Otherwise, this loop will be executed within that. Jump on no bit TA means the whenever the data is transmitted to TX pin means the TA will be set as 1. All the I already told with you in S conditional. Whenever all the 8 bits are transmitted means TA will be set as 1. Otherwise, it will be executed within this line. Whenever the A was moves to SBUF register, from SBUF to it will be SBUF sends to TX pin means TA will be set as 1. So the next step what we have to means clear TA. Clear TA means timer interflag we have to clear, and then return means it will be goes to again the second character line. So in the second character line, what is available? Move A comma C. The character C was loaded in the accumulator, and then a call trans. A call trans means it will be comes to subroutine program. In the subroutine program, whatever is available accumulator, that means accumulator what is available, C is available, that is moves to SBUF register. The next SBUF register will be transmits through a TX pin. The data was transmitted through a TX pin means TA will be set as 1. TA will be set as 1 means it will be execute the next line. Next line what is available? Clear TA. The timer interflag will be clear, and then return. Return means where it will be goes, again it will be goes this line. Move A comma E. E was loaded to the accumulator, and then a call trans. Trans means it's in subroutine program. The whatever is available in the accumulator, that will be moves to SBUF register. And the next jump on no bit TA until the data will be moves to TA. It will be waits within the line. When the data was transmitted, then the timer interflux was clear, and then return it will be goes. So like that it will be executes. Let me discuss in this simulation. We will compile it. Okay, it's fine. The next how to see virtually this output means we can connect with Bluetooth or Wi-Fi or any kind of UART protocol devices. Instead of that, here I am going to use virtual terminal to check the output. Just a second. Virtual terminal will be connected here. So in this virtual terminal, what we have to means we have to connect RX to TX, RX to TX, and then TX to RX, TX to RX, and then we have to simulate it. So we will get as an ECED. In case if I am changing some value instead of ECED, I will mention I will be change welcome. Welcome or something, whatever. Welcome. Let me check it. What will be happened? So the data will be changed. VWLCO. I hope it is easy to understand. Thank you all.